Oh no. What? Jesus of Nazareth. Oh my God. That noise is just too much. Yeah.
Timing is everything, right?
What? What? Why is the engine for this car?
This car
What is the
running
engine?
a Chevy small block.
Yeah.
350 cubic inch engine from Chevy. It's stroked to 383 cubic inches, so a little more displacement, making a little bit more power. But this is a Gen 4 race car from NASCAR, right? NASCAR stock car. They still use this generation of car in the ARCA series, but this was the car that was used in. Excuse me, this generation was used in the movie Talladega Nights. It was used in Days of Thunder, kind of the golden era of NASCAR. The cars used to make 9 horsepower, right, that range. This was that chassis.
Wow, thanks. Can you just explain a bit of this engine, just in maybe briefly?
So, in addition to the engine itself, we're going to spend a considerable amount of time talking about how to set up the car's suspension, how to adjust the weight distribution from wheel to wheel. The different components inside the vehicle here that help hold the engine on. Right? We've got this damper that controls how fast the spring is going to adjust, right? How fast the spring is going to compress and rebound. We've got a threaded rod here that will control the ride height of the car, but also has an impact on the weight distribution of the car. On top of this upper control arm right here, we've got these camber plates, and that adjusts how much the wheel is tilted in or out from the center line of the car, which will have a huge impact on our ability to handle different corners. And we'll also adjust things like caster, which is the angle from up here to down here. And the way that we do that is by sliding this whole upper control arm forwards and backwards. So there's a few different adjustments that we can do that will affect the handling of the car. So our robotics and automation program at Universal Technical Institute and NASCAR Technical Institute is going to cover the mechanical, the electrical, and the software, the coding for different types of robotic and automated systems. Everything from those robotic arms that can rotate and pick up products and materials to assembly or sorting machines that will be able to distinguish between different types of materials and move them onto a conveyor to move them from different areas of, let's say, for example, a manufacturing site or a warehouse even. The way we start that program off is really basic, right? Explaining some basic mechanical components, electrical components, and software. So this robot is an example of that, right? We've got the wheels of the robot, we've got motors on the robot, the platform, all the screws and bolts that hold it all together. Right? So we have to understand from a mechanical standpoint, because if the robot doesn't do what we want it to do, it could be because we have a mechanical failure with the robot. And then we'll get into the electrical system. So we have AC and DC, or alternating current and direct current. So we're going to explain single phase and three phase, positive versus negative systems. Understand the electrical systems, how to trace the wires, how to use tools like oscilloscopes and multimeters to understand what the electricity is doing and make sure that our circuits are powered properly. And then we got to get into the various sensors that we're going to use on our robots. This particular robot has a variety of sensors, including infrared and ultrasonic sensors. And that's going to give the computer, our programmable logic controller, the information that it needs to make decisions. Now the decisions come from the coding or the software that we're going to provide for the robot. So if we want the robot to, for example, drive in a straight line, we have to tell it to rotate every wheel, right, on all four motors at the same speed in the same direction for a set duration of time. Or we can tell it to use the information from the sensor to determine how far, how fast, and where to stop. So for example, this ultrasonic sensor, we can use it to tell the robot if I'm getting closer, 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 and then stop before it actually touches another object. And then we could use it to maybe even rotate and turn. So for example, right now all the wheels are turning. We're going straight at the same speed. All right, we get closer and closer and closer to an object, and then when we hit that range, it stops. If that range increases, the wheels start backing up. Right? So it's going to respond based on the information that the sensor receives. So inputs, processing, encoding, and outputs. And that's the basics of all robots. Now, to find out more information, check us out online at uti.edu.